Hello, everybody. Thank you for joining us for this Space Week New York 2026 virtual spotlight event. We are joined by Richard Niederlander from Spargo Space. There is a link in the chat for those who want to go visit their website. We're here to learn a little bit more about Spargo Space and the work that they do in the in-orbit refueling domain and their ties to New York. So welcome, Richard. Thank you for joining us.
Yeah, glad to be here. So, yeah, happy to start, or however you want to.
Yeah, no, just go right ahead. Tell us a little bit about Spargo, what your focus is, how you got to where we are. We'll probably dig into some of the technical stuff and then see what the future holds.
Yeah, so the concept of Spargo Space was really born in New York City. So the founding team, my sister and I, we were raised in Manhattan, growing up, going to the Museum of Natural History all the time, and just soaking in all of the planetarium imagery and micrometeoroids and meteoroids and all of that. And what that inspired in us was wanting to help spacecrafts get to space and enable that future. So what we're doing now is this in-space refueling tech, which is essentially you have depots that can hold upwards of 2,000 kilograms of hydrazine placed in low Earth orbit, and other spacecrafts would come up and get the fuel they need so that they can either continue on with their mission or continue on with more maneuverability and so forth. So, and the hardware is being developed in Florida, but the software is developed in New York City through Ava, the CTO.
Excellent. Well, that's, critically important. Everyone knows, having fuel stored in space would make so much, would raise the cap for how much further craft could go, how much larger they could be. So what is the innovation? What is the unique tack that Spargo is offering in this domain? Tell us a little bit more about, your program, your tech.
Yeah, so there's two innovations that we're proving out, which is the first, holding fuel in space for long periods of time. So typically when you have a spacecraft that goes into space, it's maybe like 5 or 10 days, like that's talking about the moon missions. Then you have satellites that hold some amounts of hydrazine, but it's typically small amounts of small quantities. So what we're talking about with 2,000 kilograms of hydrazine is 2 years or more of a lot of fuel. So what you want to avoid is like fuel slowly leaking out, temperatures causing the fuel to change states, so it becomes a gas and leaks out. These are the things that essentially keep us up at night. Want to make sure that we're not causing a potential huge hazard. And even on Earth, when you're doing refueling, you often see the spacecrafts having to delay the launch because of fuel issues. So, and when you're in space, you don't have that luxury of having a bunch of people being able to do that call and checking up to make sure there's no issues. So one of the things that we're solving here is holding fuel in space. The other issue is making sure that the spacecraft can dock to the depot without causing a collision. So typically with our pod, you have this human in the loop. The human is constantly monitoring, making sure that you don't have an off nominal issue potentially happening. But we're incorporating AI, specifically visual language modeling, that can understand its environment and then determine if it's safe to continue moving on a certain maneuver, and if so, then proceed with that maneuver. So essentially making spacecrafts autonomous through this VLM software.
Very cool. Sounds very critical. The recent Artemis mission was delayed due to a fuel issue. So we know how important and critical fuel leaks can be. So what is this a standard geosynchronous orbit? Is it variable? Can it operate in multiple different locations? How is this situated in space?
Yeah, so for our early case studies, we're targeting low Earth orbit just for ease of getting there. The biggest differentiator is going to be the the environment. So my background is a reliability engineer at Blue Origin and NASA. What that means is I got to take the avionics and the structural hardware and make that was developed on Earth and make sure that it could actually work in space. So that means looking at the radiation environment characterization, temperature characterization, and fitting it to the limits of what the materials and the avionics can handle. So that's what we're doing with the depots, making sure that it could actually work in its intended orbit. Low Earth orbit is a bit more benign, like not as rough as geosynchronous. You have a bit more protons. So this is getting into the nerd of it. You have a bit more higher energy protons in low Earth orbit, but in geosynchronous, you have a lot more heavy ions. So, and the heavy ions can be potentially more damaging, just depends on what exactly it hits.
Interesting. And no, please feel free to nerd out here. That's what we're here to do, especially for a non-engineer like me. You know, I get to learn some of the weeds in this stuff. So what is the initial market in terms of, you know, is this for certain sizes of spacecraft? Would it be universally applicable, you know, everything up to, you know, theoretically, you know, Orion or Starship, or is there a target audience or market that you have in mind, at least initially?
Yeah, so the ultimate goal is to service all spacecrafts, like small and large. The biggest issue with servicing larger spacecrafts is you have to be wary of like collision. So they have more mass, so the inertia, things in motion like to stay in motion. So it'll be a lot harder for a Starship to or take more fuel for it to stop in time. But for smaller spacecrafts like satellites and also the smaller space maneuverable spacecrafts like Astroscale has one called Provisioner. These are much more easier to handle. They can also stop on their own. And so that's the ones that we're targeting.
And then in terms of, I guess, both docking from, you know, a general perspective, but also like the fuel connection in space, would that be universal? Would you have to have different modules depending on, you know, target or market?
Yeah, that's a great question. So there's no standard right now for docking ports. NASA has tried to present universal ports, but then you have other companies presenting their own that are optimized for their spacecraft. VAST is a space station company. They recently released their own form of docking port that they'd like other companies to conform to. But then you have their own startups that are developing pretty like great docking ports themselves that have a lot of data backing them with testing, some of which are called SpaceDock and Enduralock and OrbitFab's Rafty. So there's a lot of potential customers or providers in the market, and they're sort of hashing it out right now, trying to prove out who's the best one. Ultimately, it's probably going to be whoever gets the most spacecraft customers on their to work and use their space depots or their docking ports. Then that's going to end up being the winner. But right now, we're trying to keep it as wide a net as possible and working with all the docking ports.
Very interesting. And then this is kind of just anecdotal, a question that popped up, but in your, particularly because it's so important to your industry, is the market more broadly heading towards a standardized docking model or away from a standardized docking model? And kind of how do you factor that into, you know, long term? If it's converging towards one, obviously you can engineer to that, but if it's diversifying into multiples, what kind of challenges does that pose?
There's push and pull factors here. So there are factors that are trying to consolidate by NASA and the Space Force. Most recently, Space Force had a RFI for a refueling architecture, and they actually said in your modeling, please consider, or you have to consider, no please, the Rafty or offered by OrbitFab or the MEV authored by Northrop Grumman. But then that hearing from the grapevine, that upset a lot of the startups that are building their own docking ports. They never had their say to prove out how theirs could be better, maybe be an improvement on it. And then NASA also is trying to show that these are the specs that we want to see in a docking port, which could lead to startups meeting those standards, but then still offering their own spin on things. And then at the same time, you have a lot of VCs offering funding to very innovative startups willing to build a whole slew of different types of docking port companies. So yeah, I'd say I think it's right now leaning towards more docking ports, and then eventually it'll get pushed down.
Interesting. And is this would this be dual use, or are you targeting primarily civilian or military customers? Do you believe that there's a demand difference between the two? Do you think one is more interested than the other?
Yeah, I'd say there's a lot more demand from the defense side at this time, and that's because of the contracts. A lot of space, just historically, is funded by grants and contracts through the government, specifically the military. So what Space Force is doing through these contracts is they're saying as like a baseline for some of the satellites, they're saying as a baseline, we want to see refueling. We want to see that you have the capability to be refueled in order for us to give you money to build your satellite, which then forces these companies to reach out to the refueling organizations and find partnerships and see if it could even work within their architecture. At the same time, there are forces in the Space Force saying that there isn't, like, why have refueling at all? Why don't you just design the spacecrafts to be deorbited after a few years, replaced with the greater tech? So yeah, even within the Space Force, there are these fighting elements. In NASA, it's somewhat different because it's more mission focused. It's much more, we want to get to the moon, and we want to get there by any means necessary. If you happen to prove out refueling and make it work through a refueling architecture, then that's great. And I can provide funding to that. But yeah, there's no like, we want a refueling as the mission. That could have been what Gateway was, and Gateway, for context, is the NASA proposed space station to orbit the moon. But obviously that didn't happen, and now it's fully moon base.
Interesting. And then I guess for those who are I guess interested in either the orbital mechanics or the risk management in terms of collision mitigation, particularly with rendezvous and things of that nature, you have a lot of fuel. Does that increase the need for higher risk tolerances? How are you factoring that into your early design stages?
Yeah, it's definitely a concern. So the risk architecture depends very much on making sure that fuel doesn't leak. It's always under very tight control, which means that you have to place very heightened consideration to who is docking, what type of docking ports they have, their heritage, if they've flown before, and so forth. So part of how we model that risk tolerance is through model-based system engineering, MBSE. It's an emerging field within the whole aerospace industry as well. Essentially, what that means is you're breaking up the spacecraft into separate blocks. So one block represents, let's say, the GNC, guidance navigation control. One represents the telemetry. And then within that block, you can have smaller blocks that represent all the different parts of GNC, like propulsion and so forth. And historically, that hasn't been what was done. It was more so you had managers and directors who had the high-level overview, and they were capturing that in their head, and documentation and talking to other avionics engineers a bit more haphazard. So MBSE is phenomenal, great at enabling this risk reduction. And there's also technology that's able to assign risk probabilities associated to each of these subsystems, in which case you can just apply basic math and get a system level failure probability.
Interesting. And then in terms of launch vehicle, and I guess kind of carrying the risk conversation, there in terms of, would this be usable in multiple vehicles? Is there a particular class or type of vehicle for launch that you're looking at? And are there additional, I mean, I know that the rockets generally launch a lot of fuel anyways, but there are additional considerations that you would have to take into launching something like this?
Yeah. So ultimately, this type of tech, as is a lot of experimental tech, it's like Class D. It's high risk, but if it works out and is proven, it's high reward. And you also see the government trying to promote this type of testing in space. Recently, I believe the FCC or the FAA released a way, or is releasing a way to offer spacecraft operators a way to do these experiments in space that don't require as stringent testing or flight heritage. Because right now the standard is you have to have everything very strongly controlled and maintained, not just through simulations, but through ground testing. And occasionally it may seem like they're asking for you to have already done space testing before being allowed to do the space testing. So they're hoping to change that dynamic there. And so, but we're still targeting just Class D because we don't want these high risk experiments to take place on flight critical hardware and spacecrafts, and then the smaller spacecraft. So we're targeting 100-kilogram type of spacecrafts.
Interesting. And then you had mentioned at the beginning, and I wanted to revisit it, but the impact of AI. I know you're a relatively small firm. You and your sister, hardware in Florida, software there, but you mentioned AI and the impact that it's having on your operations. Can you just talk about how you've been able to incorporate, and then the benefits that maybe it's had, what it's allowed you to do that you probably or definitely would not have been able to do otherwise?
Yeah. So the best parts of like LLMs, AI, is that you can train it on specific data sets of research papers. So I've been using Claude to, in essence, act as like a lesser than propulsion engineer to provide insights into areas that I definitely don't have experience in as a reliability engineer. And so the way we're doing that is not just basing it directly off of the plain LLM and hoping it comes across the right data. We go to the data sets and the tables and the research papers that we know are very directly relevant, but we don't know how they're applicable. So Claude has this great way. You create a project, you can upload the research papers, and then it can provide that insight. But we're also using AI as a software to maneuver the spacecraft. So this is a test we have upcoming on the ISS using vision language modeling to maneuver the spacecraft. It's patent pending as well. We'll be testing it on the Astro B. So Astro B recently is being operated by a contractor, Arcasys, and Arcasys has been a great partner. And yeah, we're going to test out that software on their Astro B.
Excellent. And that kind of leads into my final question, and feel free to kind of expand on this one as much as you want, and then we'll kind of open it up to some questions from the audience, but kind of your general timeline. So when did you get up and running? Where are you coming to now? Like, I know you said you're going to be on the ISS. Is that your first time going to space? And then what's the deployment timeline? What does the horizon look like down the road?
Yeah. So with space, it's very CapEx heavy. So even if you're a hardware first company, you always, unless you start out with the millions of dollars you need to do the testing and acquire the hardware, you have to prove it out in other ways. So for hardware, we've been proving it out through simulations, which is fine as is. But we really want to become a space startup, and to be a space startup, you have to send stuff into space. So the software is our first way of doing that, and it's happening August of 2026 on the ISS. The software is Python, gonna operate on what's called the ROS, robotic operating system, and essentially observe its surroundings, provide the spacecraft with understanding of where it is, and then convert that language into GNC commands for the spacecraft to move in the ROS, in the robotic operating system. Then, as I mentioned, this is like first time this type of autonomous navigation using AI has been done. So it's going to be pretty momentous, I'd say. And proving it on the ISS is going to allow us to eventually then prove it out outside the ISS, maybe using like on a rogue spacecraft or momentous spacecraft.
Very cool. Well, we definitely wish you the best of luck and hope that demo goes well. It sounds like it would be pretty impactful. AI does impact everything these days, and if it can help us get to more efficient in-orbit refueling faster, then I think that that's a positive. I did want to open it up and see if anyone here has any questions. I know we have some engineers, kind of interesting mix of folks here. So I didn't know if anyone on the call had a question for Richard.
Hey, Richard, Quadri here. I have a question on how you're utilizing MBSC. You mentioned that earlier when it comes to sounds like risk management for mitigating for collision as well as rendezvousing. How detailed are you going when it comes to using MBSC on your at Spargo?
Yeah. So I'll be open about what software we use. We're using YAD. It's just one of many block diagram softwares out there. There's also like Magic Draw. But yeah, there's no preference. And the way we're doing it is we're trying to get into as much of the minutia as possible. So we're trying to get down to the component level for the hardware side, and then trying to see how software interruptions would flow within the hardware, in addition to how like maybe radiation effects could impact hardware, how like the downstream effects specifically within the subsystem as well as to the system itself. So a lot of that is qualitative. There are attempts to try to make it more quantitative by saying we're making like very high level assumptions of likelihood of a component to failure in response to a higher temperature. Like if you know that it starts degrading after maybe 100 degrees Fahrenheit, trying to provide a probability to that. It does require a bit of testing. We're also looking at the literature, seeing if testing has been done at that temperature and so forth. So you don't have to spend the hundreds of thousands of dollars to do that testing. But yeah, ultimately we want to be as down to the minutia level as possible while using historical literature to fill in the gaps quantitatively.
Are you also looking at modeling the proposed behavior of the station and maybe some of the predicted movement of the spacecraft when it rendezvous or docks with your station, using MBSC, using that sort of language to predict what the behavior of the system is going to look like?
Not through MBSC. Those types of simulations are done through ANSYS. So that's how we've been able to understand potential for collisions and slowing down and so forth. So ANSYS STK is great for this. And then there's the add-ons for like propulsion, fluid dynamics. It is still expensive, but as a startup, they give discounts. So yeah.
Sounds good. That sounds awesome. Thank you.
Yeah, thank you.
Thanks, Quadri. I had one, and we did kind of. Oh no, go ahead, Matthias. Edis.
Let's see. There we go. You guys hear me here? So, Richard, quick question. You stated you're using AI fairly extensively in terms of your development work. To what extent are you comfortable that the AI you're using is somewhat of a black box and you can't deterministically look in and see how it got to a particular decision? And, however many times you run it, you may get slightly different answers. How comfortable are you with that in terms of, almost the degree of reliability you have on an AI product?
Yeah, just to clarify, is this AI for developing the spacecraft and asking it questions to inform on how to build a spacecraft, or the AI software that for visually moving the spacecraft.
For the development and how to build it.
That's a great question, also a very important question, because you're right, it is a bit of a black box. You don't, as I sort of hinted to, you don't know what data it's deciding is the best to give to you. Claude is trying to change that through its projects, and you can upload those research papers that you think are the most important, and then
Right.
it prioritizes those. But ultimately, as the user, you have to be the one to validate it, which means that you have to be very exceptionally skilled in that field. So like, I have a PhD in electroengineering, worked at Blue Origin NASA, so I have that ability to challenge the AI when I know it's doing something wrong, when others who may just want to build a spacecraft with no knowledge and just take it at face value would not work out. But then there are cases where I don't have knowledge, like I'm not a propulsion engineer, I'm not a thermal or structures engineer, and I don't want to fall into that same rabbit hole where it's like, okay, I'm now just blindly trusting it. So you still have to build out a big team. Subject matter experts are not gonna be losing jobs anytime soon.
Well, one thing I would say and I ask this question because you've been involved in space tech and the investing world, I've been looking at these models, and one of the things I've come up with is gradient descent versus set theory. Set theory having been developed now by a company called Modal in terms of its ability to generate an AI deterministic model. So you might want to look into it, MODAL, Modal.
Okay.
And they're new, so I don't think they're as far along in being able to provide the robustness that you would need that you're using now. But it's worth investigating that perhaps you could help them accelerate.
Yeah, I think I found it. Modal.com.
Well, it's modal.net, actually, I believe. Modal Technology Corporation. So there's a second modal out there, which is close, but it's not the same one.
Okay, cool.
Yeah, I'll bring it up. So be interested. I mean, happy to chat later on this if you think there's something there. Anyway, thanks, guys. I'll give the floor back.
Well, thank you very much for chiming in with a question. I think it's a pertinent question. I think everyone has lots of questions about AI, and having a chance to dig into the weeds on that one. I had wanted to kind of go back on something that you had mentioned earlier. So obviously software up in New York, you're both from New York, hardware down in Florida. So I guess just kind of talk about that dynamic. You're not the only company that operates that way. We don't have rose-colored glasses here. We know that, hardware is not, New York is not the #1 state for space hardware. Like, we're very well aware of that. So I guess from your perspective, just talk us through, you're from New York, software is still, so it still has roots in New York, but choosing to go to Florida, why did that happen? Are there any circumstances where you could have done that work in New York? So just kind of talk about that for a second.
Yeah. So ultimately, it came down to proximity to the government agencies. So we're specifically in Orlando, and that's just an hour away from Kennedy Space Center, as well as Space Force, Patrick Space Force Base. And they provide out contracts. Also, the people who administer the contracts are located there. So just being within that proximity is like extremely important. At the same time, you have Blue Origin and SpaceX. They have extensive facilities there and a lot of employees that will tend to leave and look for other jobs, and they're very accomplished. So just being part of that ecosystem, that talent pool, is very important for us. And in addition, there's Space Florida. So Space Florida is a state agency focused explicitly on promoting the space industry. And that's unfortunately something that's missing in New York. There's no targeted space, because then I'm sure every other industry would be like, well, can you give us our own special agency too? But for Florida, they do have this agency. And the land in Central Florida is very cheap. So it's a lot easier to get land and start developing and making, and it's a lot easier also to do launches and to build rockets and spacecrafts there. So unfortunately, that's a lot of things that put New York at a disadvantage. Upstate New York, I think, has that land and that could make it possible. It's just then you're a lot farther away from the money centers like New York City and the agencies
No,
as
and
well.
it's just some of those unfortunate realities. That's kind of why we exist as Empire Space, to acknowledge, some of those gaps, those challenges that space companies face in New York, and figure out how we can best program solutions. I do see that Greg has raised his hand.
Yes, hello everyone. I've got a couple of questions. The first one is, you said you started adaptive software to figure out your rendezvous proximity operations. And you said you're doing that on ANSYS or WIAD, or that's where you're modeling it. You mentioned that you're trying to go towards government. Have you looked for that at modeling it in Cameo, since that's what, and I'm not currently, but was a part of Space Development Agency, where we and everyone at SSC out in Los Angeles acquired everything through, and we're creating a standard definition of MBSE in Cameo. So just putting out that would be something for you to look at as you're trying to market to the government. You would want to have at least knowledge, or say that you are connected in that direction. And then secondly, so that's a data point. But my question is, how far along have you come with the rendezvous and proximity operations software, and how stable is it? That's one of the big concerns that people have about an operation like this. So I'm curious to hear more about where you're at. Over.
Yeah. Thank you for letting me know about Cameo. I do recall being told about it when I worked at NASA. Just tended, I think they used a bit more of Magic Draw, and then at Blue Origin they used WIAD. So it's all over the place. So okay, yeah, good to know about defense using Cameo. In terms of the stability of the software, so right now a lot of it is fully just in simulation work, as in running simulated data sets of, we give it a docking port and say, what are the movements you would make to reach that. One of the bigger things we're working on is reducing the amount of time it takes for a decision to be made, because ultimately we want it to be on the order of like a microsecond, or even hopefully a nanosecond. And you only really get that when you have really high-end GPUs. So the Astroscale has a NVIDIA Jensen Nano, which allows us to get to around 10 microseconds per decision. That still isn't the most ideal, but ultimately it's going to come down to getting smaller and smaller GPU hardware. And given the rate that this is going, we think that it's an eventuality, and we're just planning for that eventuality. So if hardware is the limitation, I think that the software is a good way to go for using autonomous navigation.
Okay, I would have you reach out or look through both MIT's CCL group and Johns Hopkins University's Applied Physics Labs, Applied Physics Lab, have been doing rendezvous proximity operation design. And they have published papers. Google Scholar can help you go in that direction. And that would be a way to dig further there. And then I'll cede the floor back. I do have two more thoughts, but I don't want to monopolize the last few minutes if Petra or Quadri have other questions.
I don't have anything else. So yeah, Greg, if you had a couple more thoughts, we still have a little bit of time here. Please feel free to keep going.
Right. Separate, but just a thought to be aware of. I know that commercial investment in space launch, they are very, very careful about the amount of fuel you put on, and that increases your, of course, risk and likelihood of additional care and control for safety and handling. So as you go forward, you probably need to look at what those specific volumes of fuel are. Because if you're launching a fuel tank, the more you put on, the more likely you are to hit certain NASA launch-defined volumes that would increase the cost and the extra assurance or emission safety assurance that you would have to spend. So be aware as you're developing your company in that direction. And then the next question, you said you were focused on LEO. GEO tends to have much more exquisite, bespoke, high-end systems that's, and again, former Space Force, that we wanted to keep and maintain. LEO, the whole mission, and I was in the RO as recently as 6 months ago, they're still doing the cheaper because they're willing to put these up, as we said, and you acknowledged, to have a refresh rate to bring on new technology. When you talk to more folks, I'd be curious to hear just off the cuff, but I would develop a long-term strategic plan is that you try to get investors. I think they will pitch more strategic geostationary orbits. Though again, yes, that costs a lot. Do you have some thoughts on how you'd address that? Again, this is off the cuff, and I assume you'll develop that over time.
Yeah.
So over.
Yeah. So ultimately, the reason we're looking at LEO first is more to it's cheaper to test out capabilities in low Earth orbit. Obviously, at that, if you're proving it out in low Earth orbit, you're not proving it out in GEO, which they have very different environment characterizations. But part of this is also to prove out that refueling first can happen again. So as background for all of this, refueling has been proven to work since 2007 through the Orbital Express program. But it eventually closed down because there was no market really to sustain it. But now that we're seeing all the space maneuverability, spacecrafts coming up, as well as clear guidelines from the Space Force and generals saying, hey, space maneuverability is a priority. This ecosystem is pretty much is appearing. But then, yeah, and ultimately to address that concern of making sure that we're not launching things that end up causing debris, it's going to require a significant amount of SDA, space domain awareness assessments, and yeah, that's also up and coming tech that startups are pursuing. I know the Space Force also is pursuing.
Yes, the other SDA, Space Development Agency, has 7 contracts looking at on-orbital space awareness, just because they're going to have 164 satellites in this current tranche and 200 some in the next. So there are a good number, and feel free to ping me. I can share the list, and you can reach out to them. I can't set anything up officially, but I'm happy to make the connection. And then the last thing on that, one of my former commanders, Rob Hauge, is vice president at Space Logistics, which is actually north of Grumman. He briefed General Purdy last month. No, he briefed Chris Kovac, General Kovac last month, and General Purdy in February. And he's leading a push.
Oh, you're cutting out, Greg.
On orbit. Sorry, I apologize. I'm on the road. He's standardizing the nozzle and working with both FINRO and SXC to do a standardization. So it's worth tracking what Space Logistics is doing. They're just trying to be the first market mover, and since they have Northrop Grumman financing, they have probably a stronger way forward. So wanted to put that on your radar.
Yeah, for sure. I know their MEV is really good. One of the not really complaints, but just comments is that it's expensive, their MEV, but I mean, that's just how it is. So
that is not the first time we have heard that in the space sector. Greg, thank you so much for the informative questions. Thank you to everyone in the audience for the fantastic questions. We are running towards the end of today's program. Richard, if you have any final thoughts, comments that you want to share with the group, that'll be that.
Yeah, I think one of the interesting things I've been seeing in the industry is there is this refueling need, but some startups are taking a different approach where they are taking solar energy to power spacecrafts that maybe just have Hall effect thrusters and powering those for maneuverability. And then ultimately you have to weigh the differences between having like chemical-based engines versus electrical engines. So impulse is a significant one if you want your spacecraft to move right away, versus taking a bit more time for it to maneuver and to move. From a military standpoint, that means if you're using it like a Hall effect thruster, you may be just sitting around for a while and the enemy can just come up and do whatever. Hydrazine also, chemical engines have fewer failure modes just because they have fewer avionics associated with them, which means less radiation impacts, temperature impacts, and so forth. But yeah, I mean, I just thought I'd mention that because that was a big theme at Space Symposium. A lot of solar energy as a service startups, space startups.
Interesting. That's a really interesting take on that. It is particularly within the market for in orbit, storage and refueling. That's a really interesting one. So yeah, I want to thank everyone who took the time to join us today. This was a really interesting conversation. I got to dig into the weeds a little bit about some of the engineering, the orbital mechanics. We're really excited for the work that you're doing. Best wishes on the demo this summer. Sounds like that could be really powerful. Keep us in the loop on that. So yeah, thank you all very much for taking the time to join us. Thank you, Richard and Ava, for the work you do with Spargo Space. I hope everyone enjoys the rest of their day.
Thank you. Thank you all. Bye.